Okay, now this time we're talking about the atomic models. What do we mean by atomic models? We explained something about the atom. We said the atom is spherical in shape. The atom consists of the core nucleus. The atom consists of electron revolving around the nucleus. So how did all these things come about? They are by evolution. All these models evolved. The first thing is somebody studied what an atom is. Democritus. He said an atom is the smallest indivisible part of everything. Democritus, a Greek philosopher, an ancient philosopher, one of the pre-Socratic philosophers. So after that, John Dalton came. He said the atom is indivisible. He stated the Dalton's atomic theory of 5 postulates, though they are all modified. Then after him, this man came that we call J.J. Thomson. So J.J. Thomson stated the plum pudding model of atom. He discovered the electron, he discovered the proton. This man. He calculated the charge to mass ratio. This man. So J.J. Thomson discovered that an atom is a sphere that consists of positively charged particles. He says atom is a solid sphere. Don't forget that everything we're mentioning here, this atom, is extremely small. It is not seen by the normal eye. It is seen by electron microscope. It is not seen by the normal eye at all. The size of the radius of an atom is 10 raised to the power of minus 10 meters, which is equal to 1 angstrom. Close. Which is equal to 1 angstrom. And the size of even the nucleus that is inside the atom is smaller. And that is 10 raised to the power of minus 16 meters, which is 10 raised to the power minus 6 angstrom. So you can't expect the atom to be something you'll be seeing or something that will be this big. I'm only magnifying it here. It's being magnified. The electron microscope magnifies something, according to what it said, to about 2,000 times of the size of that thing. So this is the atom, according to J.J. Thomson. It's called the plum pudding model of atom. He says the atom is a solid charge inside which is embedded containing positive, is a solid sphere rather, containing positively charged particles, plus, 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 plus. He now said inside it, which is embedded negatively charged particles. He said these are the negatively charged particles. He said these are the positively charged particles. He said they are all distributed in the atom, which you call the plum pudding model. And this is what J.J. Thomson said. Now, after J.J. Thomson's work, they came to do one or two things again. There should be questions that this. So Rutherford did a lot of work as well on that, on which he won the Nobel Prize in chemistry. Rutherford, alongside with his students, Geiger and Marsden, Sir Rutherford advised them to do this and do this. He told them to get alpha particle, to get a screen, alpha particle, a fluorescent source, a fluorescent zinc sulfide there. Sorry. Alpha particle coming from this source and a screen, or this fluorescent is the screen, sorry about that. So the fluorescent, the light will be gotten there. It says they are going to incident alpha particle from this radium source, radioactive source. Alpha particle is helium 4-2. So he's using a gold foil as the shield here. When it got here, the thing it passes through it. When it got here, it passes through it. It's passing through it. But at some point, at some center, when it got there, it gets reflected back. It gets there, get reflected back. It gets bounced back. They were now able to come to a deduction that there is definitely empty space in most of the atom. The atom consists of empty spaces. If not that the spaces are empty, how are we going to be seeing them passing through the atom, through the gold element there? Now, the point that the things are being bounced back at, they said there is indeed something there. They were now able to come up with a rational work that the atom consists of mostly empty spaces with a core nucleus at the center where most of its mass is concentrated, and they said there are electrons orbiting around the nucleus. He now said it is like this. He stated his own model like this. We call it the planetary model of atom. Rutherford planetary model of atom. He stated it like this. This is the nucleus, and these are the electrons all around the atom. So the Rutherford planetary model of atom states that the atom consists of a positively charged nucleus where most of its mass is concentrated and electron that orbits around the nucleus the way the planet orbits around the sun. So we call this the planetary model of atom. That was stated by Rutherford, and he won his Nobel Prize on that, which he gave his own very common statement that it has been the most incredible event of my life. It is as if you fired a 15-inch shell to a light paper and it came back to you. He gave his very common statement. Everyone knows that. So that is the Rutherford model of atom. Now, in the Rutherford model of atom, if that thing keeps happening, the electrons are going to spirally enter the nucleus of the atom. So it tells us that the atom indeed exists, but the atom is not stable, right? If electron spirals into the nucleus of the atom, then the atom collapses. And if atom collapses, why are we here? Because we are all made of atoms. So that means that theory is not complete. Then it was now completed by Niels Bohr, who stated his own model of atom. Number one is that Rutherford model is basically correct. That is the first postulate of Bohr model of atom. The Rutherford model is correct. Then the second is that, but they are not in that way Rutherford said they are. That is, the electrons orbit around the nucleus in specified orbit. Be looking at the evolution from a sphere of positive, negative, to a sphere of positively charged nucleus, then to a sphere of a positively charged nucleus, and electron in specific orbit. The electron in K orbit is in K orbit. The electron in L orbit is in L orbit. Electron in M orbit is in M orbit. Electron in N orbit is in N orbit. And they do not radiate. They do not radiate. They do not give off energy. They are in specific orbit. If this is a higher energy level, L1, L2, L3, L2, L1, L0. So an electron can jump from this state to this state. The atom is excited in that case. Then it can come back. It comes back with an energy, it comes back and radiates an energy, which is equal to EL2 minus EL1. So this will be treated more and more in the next video. Thank you.